RAID arrays, or disk arrays, are used so that you have increased speed, fault tolerance, and redundancy when compared to one single disk. RAID stands for either Redundant Array of Independent Disks or Drives. A RAID system consists of two or more drives working in parallel. There are different RAID levels, each optimized for a specific situation. Companies come up with their own unique numbers and implementations. There are many different kinds of RAID levels or RAID arrays. RAID 0 configuration is used for striping. RAID 1 configuration is used for mirroring. RAID 5 configuration is used for striping with parity. RAID 6 configuration is used for striping with double parity. RAID 10 configuration is used for combining, mirroring, and striping. Let's look into different RAID configurations and their advantages and disadvantages. RAID 0. In a RAID 0 system, data is split up into blocks and then gets written across all of the drives in the array. By using multiple disks, at least two, at the same time, this offers superior I/O performance. It involves taking two drives or more and actually striping the data across the drives. This means you get two drives, double the read and write performance, but in the event that one of the drives undergoes a hardware failure, all of the data that was stored on both of the drives is lost. This configuration is only ideal if you're going to be doing very frequent backups, or if you're going for the most extreme performance possible, such as running multiple SSD. RAID 0 is ideal for live streaming, IPTV, VOD edge server. Advantages of RAID 0. RAID 0 offers great performance, both in read and write operations. There is no overhead caused by parity controls. All storage capacity is used, there is no overhead. The technology is easy to implement. Disadvantages of RAID 0. RAID 0 is not fault tolerant. If one drive fails, all data in the RAID 0 array is lost. It should not be used for mission-critical systems. RAID 1. In RAID 1 configuration, data is distributed to the two drives' disks by writing them to both the data drive and a mirror drive. If something happens to the drive and the drive fails, the controller uses either the data drive or the mirror drive for data recovery and continuous operation. At least two drives are needed for a RAID 1 array. There is no performance overhead for running RAID 1, so you're still going to get the full performance of the drive, but you're always only getting half the capacity you would otherwise have. RAID 1 is ideal for mission-critical storage, for instance for accounting systems. It is also suitable for small servers in which only two data drives will be used. Advantages of RAID 1. Increased read performance. RAID 1 offers excellent read speed and write speed. Fault-tolerant and easy data recovery. In case a drive fails, it could be easily recovered from the mirrored drive. Disadvantages of RAID 1. Effective storage capacity is only half of the total drive capacity because all data gets written twice. Software RAID 1 solutions do not always allow a hot swap of a failed drive. That means the failed drive can only be replaced after a downtime or powering down the computer. RAID Level 5. Striping with parity. RAID 5 requires at least 3 drives and a maximum of up to 16. RAID 5 is probably the most common setup that is used because it's fast and it can store a large amount of data. So in a RAID 5 setup, data is not duplicated, but it's striped or spread across multiple disks. Data blocks are striped across the drives, and on one drive a parity checksum of all the block data is written. The parity data is not written to a fixed drive. They are spread across all drives. Using the parity data, the computer can recalculate the data of one of the other data blocks should those data no longer be available. That means a RAID 5 array can withstand a single drive failure without losing data or access to data. RAID 5 is ideal for file storage server and application servers. Advantages of RAID 5. Increased performance. Fault tolerance. If a drive fails, you still have access to all data. Disadvantages of RAID 5. Drive failures have an effect throughout, although this is still acceptable. Read data transactions are very fast, but write transactions are comparatively slower due to the parity that has to be calculated. RAID Level 6, striping with double parity. RAID 6 is like RAID 5, but the parity data is written to 2 drives, or in other words, striping with double parity. That means it requires at least 4 drives, and can withstand 2 drives dying simultaneously. The chances that 2 drives break down at exactly the same moment are, of course, very small. However, if a drive in a RAID 5 system dies and is replaced by a new drive, it takes hours or even more than a day to rebuild the swapped drive. If another drive dies during that time, you still lose all of your data. With RAID 6, the RAID array will even survive that second failure. RAID 6 is ideal for large file storage servers and application servers. It is preferable over RAID 5 in file and application servers that use many large files for data storage. Advantages of RAID 6. Increased read performance. Like with RAID 5, read data transactions are very fast. Redundancy. If 2 drives fail, you still have access to all data, even while the failed drives are being replaced. Disadvantages of RAID 6. RAID data transactions are slower than RAID 5 due to the additional parity data that have to be calculated. This is complex technology. Rebuilding an array in which 1 drive failed can take a long time. RAID Level 10. Combining RAID 1 and RAID 0. RAID 10 combines the mirroring of RAID 1 with the striping of RAID 0. This way it has the redundancy of the RAID 1, which the RAID 0 lacks, and the performance of a RAID 0, which is what a RAID 1 tends to lack. It's like getting the best of both worlds. It is best suitable for needs where both high performance and security is required. RAID 10 is ideally used for highly utilized database servers performing a lot of write operations. Advantages of RAID 10. Fault tolerant. The recovery time is very fast if something goes wrong with one of the disks in a RAID 10 configuration, because you just need to copy the data from mirrored disk to a new disk. Very high performance. Disadvantages of RAID 10. Lower usable capacity, high cost. Half of the storage capacity goes to mirroring. So compared to a large RAID 5 or RAID 6 array, this is an expensive way to have redundancy. There are many other network and storage topics left to cover. Like and subscribe, and let us know in the comments if you want more explainer videos on similar topics.